This video is the very first video in Computer Science 110 at the University of Mary Washington. As you listen to the lecture videos for this course, it's ideal to pull up your provided lecture notes and fill in the blanks when you see the answers appear during the video. Also be aware that at various points during the video, you'll be prompted to pause the video so that you can work out some problem-solving activities on your own. Then you'll be able to check your answers with the video. It's very tempting to not pause the video and just jump ahead to the answers, but one of the key goals in this course is to develop problem-solving skills and improve them. And so by actually taking the time to pause the video and work on the solution on your own before you check the solution, you'll be doing just that, enhancing your problem-solving skills. This very first video covers the topic of the software lifecycle. This is the first video in the module on the software lifecycle and algorithms. By watching the videos in this section, you should be able to achieve the learning objectives. You should be able to know the steps in the software lifecycle, define the term algorithm, identify issues that are important when communicating algorithms to a computer, and list some items included in the programmer's toolbox. Let's get started with the first section. The software lifecycle. You may never have thought about the process of creating software before. You use software all the time, but you've probably never written your own computer software. Today we'll be talking about the software lifecycle, which is the steps that computer programmers use whenever they're trying to solve a problem using software. You might guess that they have to write the code, which is certainly part of the process, but they actually iterate through a more elaborate sequence of steps. We're going to remember the steps in the software lifecycle using this acronym, ASDITM. It sounds really funny, but if you repeat it to yourself a couple times, you will cement this into your brain as a problem-solving approach that can be used for many, many problems, even outside the field of computer science. We're going to look at the individual steps in the ASDITM model and talk about what's involved in each step. So the very first step in ASDITM is A for analyze. Analyzing a problem means you have to understand it. Obviously, that's where you have to start with a problem in any domain, whether it's software development or something else. Your first step is to understand what's the problem that someone's trying to solve. When you analyze a problem, you usually have a conversation. So you, the person trying to provide the solution, has to talk to the person who's maybe experiencing the problem or requesting your assistance. So analyzing is all about talking. Your next step in the ASDITM model is to specify your idea about the problem itself. That means to actually write it down. So you're just stating the problem using plain, regular, everyday English. This allows you to communicate with the person requesting your assistance so that you make sure that you're all on the same page. You had a conversation about it, now you're going to write down some of those ideas so that you can all look at that and say, yes, that's an accurate representation of the problem. Once you have a clear understanding of the problem through the analyze and specify steps, you're ready to design your solution. And that's the step in which you create a plan for solving the problem. Once you've devised a plan, if you're trying to create a software solution, your next step is to write the plan in language that the computer can understand. We call that step implementation. You're implementing or carrying out your plan by translating your solution into something that's understandable by the computer. Now, we're all humans, which means we're not perfect. So often when we're implementing our solution, we introduce problems with the solution. Maybe we don't find the perfect solution right away. Maybe there's some errors in the solution as we wrote it up initially. And so our next step is to debug the solution. This involves testing the code and also providing fixes for it. You might wonder how the term bug came to be associated with computers. After all, it seems like electronics and bugs or insects don't have a lot in common. The term bug was used to describe glitches in electronic systems all the way back to Edison and the light bulb. It was a common engineering term. However, it came to be associated with computer software when some scientists were working on a computer called the Mark II. They were doing some performance tests before shipping the system to the Dahlgren Navy base that's located just about 30 miles east of Fredericksburg. They noticed that the system had some erroneous behavior and traced it to a literal bug, a moth that was captured in one of the relay tubes of the computer. They removed it and continued testing to provide confidence that the problem had been fixed. A technician named Bill Burke taped the moth into the maintenance logbook, and you can see where he wrote first actual case of a bug being found. So it was just a little inside joke. The people involved in the system, including Grace Hopper, a famous computer scientist, continued to refer to a computer bug and debugging the computer, which popularized the term. Now, sometimes when people hear the word debugging as testing and fixing the code, they think that particular step has to follow the complete implementation of the code. And that's actually not the case. Oftentimes, the implementation and debug steps happen in tandem. So typically, when I, as a software programmer, create software, I think about writing a few lines of code, implementing it, translating my algorithm into language that the computer can understand, and then I'll debug those few lines of code. Then I'll go back through and implement some more steps from my algorithm in a computer language, and then I'll debug those. And so there's two separate activities, but often they're done kind of simultaneously or interchanging, alternating between implementation and debugging until the full program is created and all of the errors in it have been addressed. The final step is to maintain the code, which means to correct any problems as they come up. And you've probably experienced this as a software user. If you've ever downloaded an app or a software program and been prompted to do an update on that particular app, that just means that they're going to provide you with an updated version of the code because they found some problems or they've added some additional features and they want to make those available to you. And they've done those in the maintenance steps. Those happened after they've already kind of given you the software, but over time they add on to it or fix things, and that's how they provide updates. So those are the 6 steps in the ASDIDM model. Say it with me, the weird acronym is ASDIDM, and it stands for Analyze, Specify, Design, Implement, Debug, and Maintain. Even though we've laid these all out as 6 linear steps, they're not always carried out in a linear cycle practically when somebody's developing software. Remember, I said that you could do the implementation step and the debug step kind of in tandem. You can also go back to earlier steps. If you're in the middle of implementation and you realize, hey, I didn't really understand something about what the person was looking for in the solution. You can always go back to the beginning and do some more analysis, have another conversation, document your updated understanding, and then continue on with later steps. So this is a continual cycle, and the steps can happen over and over again in the process of successfully building software. In the notes, it asks you to try to recall the 6 steps involved in the software lifecycle. Think about the acronym, and maybe draw a diagram that helps you understand the steps in a way that's meaningful to you. So take a minute, pause the video, and think about those 6 steps. See if you can remember them using the acronym, and then draw a diagram that's meaningful to you, shows how you would carry out those steps, or how those steps are meaningful in creating software. We'll be using the ASDIDM model all semester as we tackle various challenges by creating our own custom software.